Good evening. This is going to be an episode on AI programming assistance. You'll notice that the paid promotion thing is ticked on this video. That's because a friend of mine who works at OpenAI gifted me a month of OpenAI Pro so I could do this experiment. And I don't know if the rules mean that that means this is paid promo or not, but there appears to be no penalty for ticking that box and being wrong about it, and significant penalty for not ticking that box when it needed to be ticked. So that's why we are here. He's not received a preview of this video. He didn't ask me to make it, and he won't necessarily be happy with everything that I'm going to say. So but you should know that I didn't pay for the service that I used here, and you should use that information however you like to evaluate the veracity of what I'm going to say. For the last 28 days or so, I've had access to ChatGPT Pro subscription. I used OpenAI's Codex to help me write some code or mainly do the programming while I did the engineering, was how I set out to use it, and largely how I did use it. Headline numbers, which were surprising to me. I didn't look at these at the time. I only have done these counts just now, but I had it write for me 388,657 lines of code, so around 14,000 a day. If you were measuring that lines of code metric, then you can expect your productivity to look pretty good. I think if you're measuring your productivity by lines of code, you're an idiot, to be clear, but it doesn't stop people doing it. Why is it wrong to measure productivity by lines of code? Well, if you can solve a problem by not making any new code which you have to maintain, you should definitely do that. If you can solve a problem by eliminating lines of code, you should definitely do that. Having access to this AI assistant changes how I wanted to use code, and I think that that is a change that it should make to everyone else who uses it as well. Okay, so I used it for 2 weeks with GPT 5.4, generally on extra high reasoning model because, hey, I wasn't paying for it, and I had it work on some problems that I really wanted to solve. This is I thought carefully about how I should try and evaluate this stuff, because I was always my intent to make a video about it. But I thought, okay, what I will do I could give it some problems that I already solved and try and give it the same information I had to start with, and the same, and see how it does, and try and compare it to myself in that way. But I don't see how I could do that fairly. Like, yes, it might have allowed me to do the same test on ChatGPT 5.4 and then 5.5, which came in about halfway through my experiment, and then compare it to some offline model or something. But I don't think that was the best use of the resource that I had. So I decided what I'd do is I'll take some problems where they can be addressed by creating new software, and I really do want the problem solved, and I will try to get the problem solved using the help of Codex and OpenAI's reasoning GPT, to see how well that works. And so I started relatively small on a pre-existing project that I wanted to make some changes to, but I knew that those changes needed a fair amount of typing in of code, and I didn't want to take the time to do it myself. So this was a case where I was pretty clear with how I wanted it to be, what I wanted done and how it needed to be structured, and I could tell it the spec in relatively short period of time, and relatively small amount of typing. But I hadn't wanted to sit there and write the 3,000 lines of code it would take and then debug that and whatever, because I didn't want to spend my whole week coding. The problem wasn't big enough to put my time into it, but when I don't have to put my time into it, it became the economics were different. So I asked. So I had GPT-5.4 work that problem, and it did great. To be honest, it did the code I would have written in the way I would have written it to address that problem. Wrote tests, explained how it worked. I felt it asked slightly fewer questions than perhaps it should have, and so I had to watch what it was doing and interrupt it when it had made an assumption that was not the assumption I wanted it to make, and that's persisted throughout the later attempts that I've made. So, but with that, when I had a relatively not totally narrow, not particularly original, but just the code needs writing kind of problem, it was a pretty good accelerator of that. And it took me, this was the first couple of things I tried with it were in that category, and it took me like a day or so of using it to get the things that I wanted done as a total newbie. So that was at least 5 times, perhaps 10 times faster than I would have done it on my own. It was 10 times faster than it's not a principal engineer scope problem. I could have done the same work as a junior engineer, but it would have taken me the same length of time. And it would have been 10 times faster to use the GPT to do it and Codex. So I was very impressed with that initial experience. Then I moved on to I've had a idea in mind of how I want to improve my golf this year using software, but again, it would have taken me, I thought, a few months to iterate on the software, and it would have been a bit annoying to have been sat in my chair typing in code for that amount of time. So I thought, okay, I can get the AI to help me with this. Let me just give it the outline of what I want, and we'll work on that. And so that class of problem was the most of the rest of the time that I've spent with it. So probably another 20 days was into that kind of work, and that's where I've observed some really interesting kind of patterns in how useful it is. So if you do one of those small tightly scoped things that I started with, I think you probably will also see a 5 to 10 times speed up in what you do. When you have a problem where it's a bit vaguer what you actually want, and that vagueness is not because you can't be bothered to type in the spec, it's because you don't actually know what you want. You just want to see something in that area, like something in this category built. You can get it to be like maybe 100 times more productive than you yourself, because it has this it will make assumptions. As I've said, it will just go in a direction and run with it. And in that case, in that scenario where as a human I'm looking at a blank page and thinking I've got to make a choice here about which direction I go, and I'm going to have to sink like a week into whatever direction I pick, so I better pick the direction correctly, and I'll get caught up in that tyranny of the blank sheet, perhaps. The AI will just make a decision. It won't think about it really at all, and then it will write the code. And yes, it means that very probably the version that you're going to first look at that it's built for you is not going to be anywhere near as good as the first version that you would have built yourself. But from there, you can restate the problem or steer it, and it's up to you. Actually, sometimes I've felt that the first draft it built was pretty close in a lot of ways to what I now realize I actually wanted, and I can steer it from where it is to there with a few prompts. And sometimes I felt that the fundamental thing was had gone in the wrong direction, and then I'll rewind Git history, bring up a new instance of Codex just before the decision to go in the wrong direction was made, and say, here's, you can see where we are. I want you to go in this direction to finish this, and that also worked fine. And you don't need to. So if your problem is a certain kind of hill, amenable to that sort of hill climbing type algorithm or just build something that's like this, then we'll stand there and see where the upwards direction is, and we'll just go in that direction. It's a huge accelerator, easily 100 times, perhaps even 1,000 times faster than I would have done it on my own. Not being hyperbolic with that. That's my actual estimate for the numbers on some of the tasks. The flip side of that is sometimes the productivity multiplier you get is less than 1, and that, or it feels like that. Like, I have not done the same thing twice and seen how quickly I could do it. But there was a specific class of problem where I knew the path to success was very narrow. It has, if you do these things in this way, then we will succeed. And if you do something like that in some other way, then it's just useless outcome. With that shape of problem, it doesn't do very well because, along with being that shape of problem, the problem I had was quite complex. And so as we ran out its context window, it was then compacting the context, losing some of those things that are very critical to the success of the endeavor, and going off and doing something else. And so I'd set sort of a rule for myself, which I actually wouldn't recommend you do unless you are an AI company. I wouldn't say you should go in the direction of mandating that your engineers mustn't write any code and they must prompt the AI to do it. I'd set that challenge for myself because I'd heard that it was a trend going around, and I wanted to understand, is that even sensible? And I think it's fine in the majority case where your problem is amenable to the sort of hill climbing and, head off in a direction and then correct later. But when there is when the shape of it is known to be, there is a narrow path to success, and if you stray from it, you are not going to be successful. I found that I wasn't really getting a huge productivity boost from the AI, and it was very stressful because I had to watch its output continuously for when it started to deviate from the path that would work, and then interrupt it and say, yeah, no, you have to do this, not that, at those right times. Otherwise it would write thousands of lines of code in an unproductive direction. And then once that had happened, it was very trebly hard to correct, because now you're not at that point. I wouldn't just be fighting against the inherent training of the models or its fine tuning or whatever, but I'm also fighting against the context it can see in the project, which is now indicative of let's go in this direction, which is not the direction that we must go. So if your problem is of that shape, then you won't get a boost from AI. Now, I want to say very clearly that a lot of problems will look like that shape, but if you're sufficiently skilled, you can work out a way to make them the other shape. And so I had a few of those where early on, the only way I could see to solve it was try to walk this narrow path. And with a little bit more practice, I was able to reshape the majority of those into here's a destination we can go to, and then from there we can walk up a hill to an acceptable solution. And I think that might be where, with the current technology, the major skill in software engineering assisted by AI is in finding a way to phrase your problem so that it's amenable to that shape of solution. And it's very possible, I will freely admit it, that the problem I had, which wasn't like that, is a skill issue on my part, that I couldn't see a way to make it that shape rather than an inherent part of the problem. But the reality is, if I had been paid to solve that problem, forcing me to use AI for that felt like it was taking about 15% longer than it would have taken me to do it myself. And it was much more stressful to have AI do it than to do it myself, because I could not ever take a break from watching the screen in case it started going off into the middle of nowhere. So yeah, I would say maybe don't mandate that you must only use AI. Not just yet. It's not quite general purpose enough for doing that yet. There's a couple of other things I think businesses need to watch out for here. So humans, well, making the coding faster means engineers are making decisions about what to build at a faster rate. But we're almost certainly not getting feedback from the real world on whether those decisions are good or not at a faster rate than we were. I mean, perhaps a little bit faster, but not at the same kind of multiplier as the decision rate has gone up by. And we get more confident the more decisions we make, and we lose confidence if we find out fairly rapidly after making a decision that decision was bad. And compared to where we were before, if you're making software 100 times, writing code 100 times faster, you're making still roughly the same number of engineering decisions. So you're making now decisions at 100 times faster rate, and we're not getting feedback from the marketplace or the actual users of the product or anything, except at roughly the same rate that we were getting that feedback from before. We're going to grow in our confidence in our decision making because we're just making more decisions. That's how psychology of humans works. And we're not going to have as much chance to correct the accuracy of our decisions as we have had before. So I think that's something to watch out for. I don't know that I don't think I've got a control that I would suggest businesses put in. Maybe as a thing for managers, like, be a bit disciplined about how much change you're allowing into a product in one development cycle. Like, it's still got to be tested and accepted by users before it's good. And changing 20 things in a release instead of one thing in release isn't actually 20 times better. It just means if they decide they like it, you don't know if you had 18 good things and 2 bad things, or one good thing in there. And it's not helpful to just confuse your data signal. So maybe you don't want to go as fast as you now can go. Maybe you want to go speed up to where your data pipelines can keep up, and work on ways to make that faster if that's now the bottleneck. But expecting all your engineering to be 10 times faster, it might be, but that might not be the right way to do it. The other thing, preconception I tried to challenge was, in the previous episode I said, I think you would need something other than code to review, and I don't know how to prompt the AI to generate that yet, and I think someone should be working on it. So I do still think we need something other than source code to be reviewing, because I found I was absolutely the bottleneck in the process. Or if I was going to look at the code and approve it, I would not be getting that 10 times speed up or that 100 times speed up, and certainly nowhere near 1,000 times speed up. I'd maybe be getting like 1.5, 2x tops, which would have made the economics of it totally unfavorable. I wouldn't have completed the projects that I completed if I'd been reviewing code and approving it. So what I was doing for this month was reviewing what the AI claimed it was doing at the engineering level, and assuming that its code truly did that, and then user testing of what it produced to see if it met the user requirements of what I wanted. And I think that was an acceptable way for me to behave, because I was doing this stuff just for myself. I would not be comfortable with that being the process for a product that is getting shipped to actual, real customers, real users, in a commercial setting. It doesn't. I did work on, can I specify in enough detail for a AI to build it what I want that optimized for review system of engineering system to look like. And it's still true that I can't do that in enough detail to have it like build it from the ground up. Getting closer with each iteration, but I would say still very much a long way away from being able to do that. But I do still think it's a good idea. I think it's in practical terms necessary to have that in order to move fast enough, to scale your capacity to validate the engineering output of the AI in step with how much the AI is accelerating the ability to produce software. I think it's necessary to have something, and the most promising direction I have was, indeed, it's a graph-based language, which and the purpose of that is to exploit the self-similarity of graphs at various levels of computer software. So I can look at CPU instruction level graph if I want to. If I was a mini code engineer or microcode engineer, I could look at below that level, and if I was and view that as sensibly as a graph of like, these things come in, and then this node is called whatever it is as the CPU instruction, the core instruction set, and then this is what comes out. And you can view the same thing at higher levels. So you can have a thing that's at the similar level of abstraction to normal source code in Rust or C++ or Python or JavaScript or whatever. And then you can have obviously there's a level above that where you're just looking at the level of functions, and then levels above that where you're looking at the levels of services and service calls, and levels above that and above that, as high or as low as you want to go. And I've had Codex build me demonstrations of that with different ideas of what the fundamental abstractions are. So I've built versions where they're all the edges just a data, and so if you want to talk about locks or other kinds of thing that aren't exactly data. You have to make them look like data. And I've built versions where every kind of resource has its own kind of edge and compromises in between. And you've got all the same options for what your data structure modeling is going to be like as you have in other programming languages. So that needs to be selected. And then you've got choices about, the aggregation point. Is that done automatically, or is it for the engineer to demarcate the points at which a graph becomes concealed inside a node when you zoom out? Or is that automatic? And you've got choices about where you want to place the boundary. So the purpose of for this to be valid, right? It has to be deterministic processing from the level of the graph, the level that you review as a engineering reviewer, down to the machine code has to be a deterministic process. And so you've got a choice to make about how you want to deal with that. Like, are you going to have the bottom layer that your graph system deals with be, well, here we're just going to generate some Rust code or something and hand it off to the Rust compiler, and we trust that to be deterministic along with the assembler and the linker and all of that stuff. So that's my boundary. Or do you want the bottom layer to be like LLVM intermediate representation, or do you want it to be machine code, or do you want it to be something higher level than all of that, or lower level than all of that? It's that's an open design choice that must be made. All of those options are in some sense equally valid, but anyway, for what it's worth, my favorite of the designs that I've pursued and specified and respecified looks like LLVM intermediate representation at the bottom. It's then got its own like system library that has the POSIX system calls or something like them in it, just directly wrapping Linux syscall. So it doesn't create C like LLVM in IR or Rust like or anything. It's its own thing. And then you have your own standard library that's in the graph language. And again, you're going to steal the best ideas you can from all the other languages. You'll have your own data modeling. Again, you'll steal the best ideas that you like from other languages. And then you will want a way to import existing projects into that language. But I found that the LLMs were so good at reading existing source code and generating this new graph language that they've never seen, but generating the semantically equivalent code in this new graph language, that I didn't feel like I actually needed to bother with a custom importer or with a compatibility layer. Like that is a task you can hand off to the LLM. But then once you review the graph and verify that the graph does what you want, you're then in that world where that's all you have to look at. And so you can very quickly get to, here's a nice UI for looking at the graphs. Here's a nice UI for looking at what's changed between this graph and this graph, which is how you're going to review actual changes the LLMs proposed. And yeah, so that was the approach I thought had the most promise. But I don't have it. It's not a level of refinement where I think it's anywhere close to being usable, and I wouldn't want to. I don't have this problem. This is a problem that people doing real engineering still in this age of AI have, and I'll be honest, I'm not one of them. And so I would suggest one of you works on it, because it will make ultimately your engineering faster. But I'm in the realm of saying, if I were still working and I was working at an AI company, this is what I'd be advocating that I spend my time doing, is solving this problem. But I'm not interested in actually doing that. I'm more interested in getting better at my music and my golf. And so I've become one of those people who retires and then tells people what to do from outside the industry, as though it means anything. Make your own decision. I shall not be offended if I'm ignored. I think that's all I have to say. I will do another video to show you the golf stuff, but I wanted to separate this one because if I don't mention how it got made, then I don't have to put the sponsored product tick on the golf video, and I'd rather not have it there, because I think there are plenty of people who will just not watch it if I have to have that tick on it. So I may be very wrong in that perception, but that's partly why, and also because I want to talk about golf in that, not the software, but like the reason for it, and it's a different audience of non-software engineers, so I wanted to keep the software engineering part in here. I'll end with a few like slightly interesting observations. So at one point I was doing some reverse engineering work on a network data packet that I was pretty sure contained a photograph of a golf ball, and the AI assistant was trying various ways of decoding it, or unpacking it, and saying which ones had the statistical correlation with each other, like that. So there should have been 4 images of the same golf ball in this network data packet, and so it was doing this statistical analysis of like these ones are most similar to each other. And I said, okay, just make graphics of your favorite of the solutions that score the top 20. Make a graphic of what it decodes to, so we can look at it, was I think literally what I said. So I made that graphic, and it said that the one with the best statistical correlation by a long way is ID 47, I think, or something like that. I opened up the graphics and then told it ID 33 is clearly the right answer, because it's the only one where the pictures look like they're pictures of a golf ball. And what was interesting was, at that point, it then uploaded that PNG to itself, ran it through its vision model, because it's a multimodal AI model, and went, oh yeah, that's a golf ball, all right, and the other one that I've just looked at clearly isn't. So I agree with you that it must be number 33. So I was like, okay, cool tech demonstration, but it's been clear to you from the beginning that we're trying to decode pictures of a golf ball. Why have you not used your vision to look for, is it a golf ball or not, until after I've done it? Like, that was a bit of an odd, like, more than once through the process, but that's the first and probably still the best example of it. More than once I've found it has capability to do something, and it doesn't appear to know that it has that capability, or doesn't seem inclined to use that capability until you explicitly ask for it. And that's quite frustrating to me as a new user, because I don't know what it can do, and I feel like I'm having to micromanage it into using what its capabilities are. And it would make more sense to me if it knew what its capabilities were and what they're good for, and would just use them when it would help. That's what a normal human person you're interacting with would do, and it's very weird to have a AI that has these vast capabilities and doesn't know when to use them, or seems to choose not to use them in places where they would make more sense to to be used. That feeling of having to ask it explicitly to do things, or perhaps it won't do them, was the only real time I felt after that incident and a couple of others, I was much less happy with the service for a day or two each time, because it always meant in the back of my mind for the next few days was, I'm having this trouble getting it to solve the problem that I want. And like, is there a magic word I should be telling it to get it to use some skill that it has that would just make this problem go away, that I just don't know that it can do? And like, how am I meant to discover that if it is the case? And that lack of, like, being unable to be confident that I'm getting the best out of it was a bit strange and disappointing. Anyway, I hope I've told you some interesting things. I'm very sure that I will not have answered every question I could have answered, and I don't know what you care about unless you ask me. So if you have further questions about what it was like to spend a month with Codex, please put them in the comments or just get in touch directly, and I'll answer them, or I'll do another video to answer them if there's, if I think it's generally interesting and it will get seen by more people that way. And finally, I will try and figure out how much API cost equivalent it was. So I had access to the $200 Pro plan for personal users. I got quite close to the weekly limit in the final week of using it, but other than that, I was nowhere near the limits as far as I can see. And I will try and find out, if I had to pay API pricing, what that would have cost me for the 4 weeks. And if I can find that out, I'll put it in the video description or in a pinned comment. Anyway, thank you for your time. I hope you found this interesting, and please get in touch if there's anything I can answer for you. Cheerio.